Hello everyone. If you are connected with machine learning field in any way, you must have heard these keywords more frequently. And the top keywords are AutoML, stacking, blending, MLOps, machine learning observability or monitoring platforms, model registry, data artifacts, code artifacts, model artifacts, feature store, online feature store, offline feature store, cloud AI, enterprise AI, machine learning platforms, machine learning libraries, machine learning engines, various algorithms, hyperparameter optimization, ONNX models, variety of model types such as PMML, JSON, H5, POJO, CoreML, etc. So these keywords are not only the keywords, they are very important and essential part of a modern and scalable machine learning pipeline. I discuss these technologies in depth with my clients, with my fellow AI engineers, and we understand these features. They really help a particular machine learning platform to be more enterprise ready, to be more scalable, to meet the business need. So I decided to create a tutorial where I could explain most of these keywords in very general way with the thought process of having a machine learning pipeline always in front of us. So we could very easily understand how these different technologies really fit in the grand schemes of things. So that was my objective in this tutorial. Hello everyone, my name is Avkash, and in this video tutorial I'm going to focus on 5 key things which are related with machine learning pipeline. First one is machine learning platforms, libraries, frameworks. Then we are going to focus on AutoML, stacking, blending. That is part of machine learning framework. Third, we are going to look into the machine learning observability or monitoring platforms, which also calls MLOps. Next, we are going to look into the model registry, how and why a model registry could be very beneficial for any enterprise or any organization which is using machine learning. And finally, we are going to look into the feature stores. So these 5 key concepts are deeply explained in this AI or machine learning pipeline. I have used a mind map to keep you focused whenever I'm talking about these key technologies, so you could understand that what we are talking and in grand schemes of things in ML pipeline, where the technology really fits and how it provide advantage to overall machine learning pipeline. So without further delay, let's get ourselves started. So here is the mind map for the AI pipeline or machine learning pipeline, where anybody's objective is to solve a problem through machine learning technologies. First, machine learning training system, cloud versus on-prem, we are going to look into. Then we are going to look into the AutoML part. AutoML, blending and stacking altogether, number 2. Number 3 will be the machine learning monitoring platform or observability platform. Number 4 will be the model registry, the role of model registry. And the number 5 will be the feature stores. So let's go to inside our AI pipeline mind map and try to start understanding these things. So let me zoom into my pipeline here. So everything for machine learning pipeline starts with the data. We have variety of data available depending on what kind of enterprise it is. Depending on enterprise, you have stationary data sitting on your data warehouse, data lakes or RDBMS, etc. Or you have live streaming data. Everything is coming, pipeline logs are coming, for example. IoT devices are sending real-time signals. Servers are sending real-time signals. Search is happening. It could be anything. So variety of this data is coming, and the very first part in your machine learning pipeline is that you are acquiring all of data. So it means your first step is the data acquisition. You are acquiring all the data, and the next step is you need to understand whether this data is meaningful or not. It means you need to wrangle with your data. That's where the cleaning and imputations, joining the data, as well as the anomaly detection or the ambiguity detection, outlier detection, all those things are part of data wrangling. Somebody does small, somebody does big, depending on where your needs are. However, everybody has to wrangle with your data to make sure your data is clean, merged, and at least it's a one group of data that has to go to step number 2. And that's where we call it pre-processing. The pre-processing part of the data is to look upon from machine learning perspective. Before pre-processing, you were looking into the data, but you were looking for the data based on quality perspective, validity perspective. What is your data? How good is your data? What is missing in your data? Is it valid or not, depending on the problem you are solving, depending on what your data should be. So all that criteria were part of data wrangling, but when you came to pre-processing, now your mindset is changed. Everything you are going to perform on your data, it's part of pre-processing, but mindset is towards machine learning, because once you will process this data and you will generate your output is going to be fed into a machine learning system. It means the data must be able to understood by the machine learning system, depending on whatever machine learning method you are going to use. So that's all pre-processing, and that's where the technologies such as unbiasing, normalizing, labeling, regularizing, balancing, feature engineering, encoding, etc., comes in. List could be very long. Depending on data scientist capability or the tools an organization is using, or a combination of various factors, the list of pre-processing could be very big. If you are doing manual, it's very tedious work. That's why the platforms comes very handy. Companies like DataRobot, H2O, Databricks, Dataiku, these companies are building application over application over application to automate most of these things. And majority of pre-processing now these days is actually done by machine learning. So the machine learning methods are applied on your incoming data in the pre-processing stage, where they can generate a meaningful data which is machine learning ready. If data has bias, that can be identified. Outliers can be detected from machine learning perspective. If there is an ambiguous data, it means the class is not balanced. It means the information is there is skewed toward a one particular class. All those things can be pre-processed to make sure your data is machine learning ready. Now, your machine learning data is ready. It means this is the time where we can start talking about the machine learning platform itself. And that's where the complexity in our topic start happening now. As you could see here, that we really have very good content in front for us to go and deep dive. So please bear with me if some of the concepts are new to you, and if you try to listen 2 or 3 times, I'm sure you will be able to make sense of these. So once your data is machine learning ready, now that data is fed into the machine learning pipeline. At this time, we are not looking into the feature store for a while. Just assume that does not exist there. So machine learning pipeline, it could be local or hosted. It means you are running a bunch of machines or runtime environment on your local environment, or everything is set on cloud. If you are in cloud, there are different methods. If you are on-prem, there are different way to do the same thing. And there are lots of machine learning libraries or engine. It's depending on whom you say or talk. People will say it's a library. So for example, people can do machine learning using scikit-learn. People could do using H2O. And there are, depending on what kind of problem you are trying to solve, there are very specific machine learning libraries for that. If your data is time series, you are trying to model your data differently than regular transactional data. If your data is unstructured, it's text, it's video, audio, something like that, it has to be processed differently. So there are libraries for that. So all those libraries and engines, they come and play together to generate your machine learning model. So in the bottom of anything, when you do machine learning, you pretty much select an algorithm. That algorithm is selected based on your need, what your problem is, and then your expertise comes very handy, because if you have seen the problem in the data, you know that particular algorithm is going to help you, and that's where you are going to select it. Experience, knowledge, that's all come very handy at that point. However, in last 2-3 years, the AutoML has taken over the world, where knowledge of frameworks and libraries and just does not even matter, because once you build your machine learning data ready, you can feed everything to a system where everything will be used and your model will be generated. So now we are coming into, so if you see here that basically the machine learning process is experimentation phase. You experiment, you use an algorithm, do some experimentation, and you get a model. You validate that model. If model is good, not good, you go next step. Model is not good, you re-experiment it, you tweak again your test set, and you select another algorithm, or within the same algorithm you tweak the parameters and you got another model. So what is model? Model is nothing but just a code. It's a learning from the incoming data, and the way it's represented based on the library you are using. If you are using library X, the understanding from your data will be written in the format of X could understand. That's where it comes, that if you are using TensorFlow, which is a machine learning library, the understanding of your data will be done the way it can be understood, and then the model will be generated that format which is understood by the TensorFlow pipeline. However, then transformation could be happen. You can take a model from one particular platform and convert to other, and that it can be understood by other engines too. And we are also going to learn. So let's go a little more deeper into the machine learning pipeline, and we are coming a little down. And here is your machine learning training system. And a machine learning engine such as TensorFlow or the scikit-learn or XGBoost, LightGBM, H2O, etc., they all is a combination of lots of algorithms. And these are is general purpose algorithm and a special purpose algorithm. They are depend on what type of problem you are solving. Supervised versus unsupervised. Within the supervised, depending on what you're really trying to, there are tree-based algorithm. There is like generalized linear model algorithm, which is works differently. So depending on what kind of problem you have, there is a stack of algorithms available, and a machine learning library or a machine learning engine is a collection of lots of these algorithms implemented in a way that they can process your data. Now comes the distributed processing. The distributed processing means the machine learning can be done on a scale. Libraries like scikit-learn, they are limited to your runtime environment. If you have massive amount of data, you are going to exhaust the local resources because your data cannot be fed into machine learning system. That's why you need a distributed machine learning capabilities, and that's where the H2O AI, MLib from Databricks, TensorFlow, PySpark, these are the libraries. They can do training on a scale. And a scale means now you have massive amount of data can be fed into the system. So that's where the scalability comes here. So now we can look into that an engine or library is a collection of algorithms, and for each algorithm you are going to get a model. So if you are trying to do experimentation, what you will do, you will select 2-3 different algorithms. You try to check your results and see if the models are coming with proper accuracy as required for your business. And you are going to use those libraries. And these models could be a variety of models. That's why I have some examples here. They could be pickle file, could be JSON, could be H5, could be Pojo, which is a plain old Java object, could be core ML type, could be PMML type, or could be XYZ or ABC. Because you can come up with your own model type, because the model is nothing but the learning from the given data. And that can be converted into any language. You can write a model in C++, in Python, in Java, in Scala, honestly. Because it just, model is not something out of this world thing. It's just plain information, what was given in the in your incoming data. So let's go a little more deeper into ML training system. And as you could see here, that we are going a little more deep inside, and now a collection of libraries comes in front of us. And as you could see here, that we are looking into the deep learning or the neural network based libraries such as PyTorch, TensorFlow, Chainer, MXNet, Caffe. These are the different libraries or engines which are designed for neural network based machine learning. And that's why it's called the deep learning. The other libraries such as LightGBM, XGBoost, H2O AI, open source, Spark, MLib. MLib also support deep learning too, and scikit-learn. These are all libraries. They are designed for statistical machine learning. And depending on what you really want to do, in each type there are a variety of algorithms. And that's also supervised versus unsupervised data. What you really want to do. And all of these deep learning versus the statistical machine learning library, they process your data. Data has to be formatted properly depending on these library, but they support a universal set of information like a data types, numeric data, categorical data. It could be text, it could be encoded, 0 and 1 value, numbers, real, float, all that thing. It means that you have to make sure that your data is understood by the given library. If you are using images, you have to decode those images and convert them into a numeric format. Same thing with audio, all that thing has to be converted so that it can be understood by this library. Next, if we go a little more deeper, we have these cloud platform such as Microsoft Azure, Amazon, AWS, and the Google Cloud Platform. Now you could do the machine learning at a scale by using any of these platforms because they give you the distributed machine learning capability with non-distributed tree, which is want to do with a very small runtime environment. And the other platforms such as Data Robot, H2O Driverless AI, Data IQ, there are several others. There is a massive amount of companies they do. Amazon SageMaker too. These are all, some of them runs on-prem, such as H2O Driverless AI, you can run on-prem. Data IQ, they have DSS, Data Science Studio, you can run on-prem, but they also have platform which runs in cloud. SageMaker is designed for AWS environment. Whenever you are using any of these libraries and you are trying to choose these platforms, the machine learning libraries, they are all packaged into. So if you are using H2O Driverless, it's a combination of LightGBM, XGBoost, H2O AI, scikit-learn, and TensorFlow, Keras, they all are coming into inside here and playing their own role. If you are looking into SageMaker, same thing, it's a framework. So you could choose what you would want to do it. You can let SageMaker to try what it's supposed to, select whatever library framework it want, or you can choose it. So just for understanding, you can think about that when we go deep into a machine learning training system, it's a combination of various properties, systems. They are working together to solve one single problem. Just understand these signals from your incoming data and try to learn from it and generate a model. And that's where it is. Your whole process is you want to give a one model which is the best among all the models are created. And that's where the concept comes. What is AutoML? We can go a little more deeper inside, and now we will look into the concept of AutoML. So far we have understood loosely, you have one algorithm, it generates one model. So if you would want to build a best model, you are going to use lots of different algorithms which are acceptable depending on your problem, and you are going to get lots of models, and these models will have accuracy, and some will have better accuracy, some will have lower accuracy, and you will select one best model. So this is what you are doing. If you are a data scientist, you are doing manually everything. So if you choose one library, for example H2O, and you have selected, you are solving a supervised problem, so you have selected the random forest, distributed random forest, you also use the support vector machine SVM, you also use the GLM, generalized linear model. These are all algorithms, and they are all generating models for you. So just for one library, you have choose these 4 algorithms. Now you think that you are not getting what you're supposed to get result, so you have added LightGBM also in your mix. And now LightGBM also has the boosted tree. Now you are using boosted tree algorithm. Then you decided to use XGBoost2, which also support the boosted tree. Now you are using. So you have 3 different libraries and 6 to 8 algorithms. Now you have also added the scikit-learn in the mix, and you got almost same set of algorithms which you also had the H2O. You can now you have almost 12 to 15 different algorithms in different libraries. They all are generating models for you. That's what is happening here. Multiple algorithms coming out from multiple libraries and engines, they are generating your models. That is what is automation here. What if you have a system which just generate the models depending on each algorithm, and now within the algorithm, now you are actually switching the parameters. So if you have a parameter and its value can be from 1 to 10, so you are actually using the same algorithm and running 10 times. One time parameter value is 1, second time parameter value is 2, third time parameter value is 3, and you are doing 10 times for the same algorithm. What if there are 2 parameters now? What if there are 10 parameters? Within the same algorithm, you are playing with the parameters, and that is called the hyperparameter optimization. You are playing with parameters to find what is best within a single algorithm right now. So very soon we are talking about tens of thousands of models are being generated, and that is beyond any human capabilities to just manage all that thing. And that's what we call the AutoML framework. So AutoML frameworks, they let you do 3 key things. They can let you choose variety of machine learning engines, so you can select as many as available in your framework. Second, they can let you choose variety of algorithms applicable to your problem within the each library. Second, third, within the algorithm, they can let you play with parameters depending on how many parameters settings are and what is the parameter range value can be. And now you have this whole 3-dimensional matrix of X and Y and Z. And thus, if you try to mix this all thing together, you are going to get massive amount of models coming into. And that's level 1. And that's what the AutoML in general is. And if you think about, if you have AutoML framework, you don't really need expertise, because you just pump all that data into a system which can AutoML everything for you, and sooner or later you are going to get a best model. Then you look into the pipeline, see how the best model came, you look into parameter, and that's what you are going to save it. And if you are expert enough, you take those early indicators in parameter, if you could tweak by yourself, and you can even achieve higher accuracy. That's what AutoML does. Next comes the blending or stacking. So all these models which you have generated could be used for selecting the best winner model. That can be done. Second step is that now you can actually take these models, combine them together, and build a new data set, and then use this data set to build a new model, because you are using these models because model already have all the understanding coming out from your source data. So these models can be used to actually stack them together to build a new model. And that's why this method called the blending or stacking. If you look into the Data Robot AI platform, they will say this is a blender model. It means some of the models they have created in this AutoML pipeline, they selected few models based on certain criteria and blend them together to build a new winner model. And that's where you can understand that blending or the concept of stacking. It's a one more level of AutoML where you are trying to get your winner model. So you got collection of models. So collection of models means you selected few models which are the best ones, because you are not going to play with tens of thousands of model. You are going to get 5-10 model, and then you are going to evaluate them. And while you are reducing your numbers from 10,000 to 10, you are still applying the model evaluation techniques. You are finding out the best accurate model for your need. Is this model can be explained? What it's really doing? Does it have the explainable capabilities? And when we talk about explainability, it really gives you that out of given feature, the information you have given, when this model was being trained, what is the feature importance? Out of 10 features you have passed, which particular feature has the highest importance? Feature impact. All those things can be explained. If your model is generating a prediction, it can explain that why I am predicting that score. If your model is for the heart disease detection and you are figuring out based on a patient data that this person might have heart disease, you really want to know why this person has the heart disease. Then model will say that these are the features which provide highest impact to me to give you this answer, and this is the importance. There could be several techniques such as LIME. There is SAP, SHAP. So those things all comes handy. So we have looked into conceptually that ML training system, how they work together, how they work in cloud versus on-prem, the role of various engines, libraries comes together, how we mix all that thing together in the concepts of AutoML, stacking and blending. So we have got a good understanding of that, and now we have a bunch of model available for us. They are being evaluated, validated, and based on all that check passed, you have a winner model. That's where you got the winner model in your hand, and that model will be used for deployment, and prediction will be started, and then you are going to get a score of prediction. So that's where we have seen. However, when your training was going on, your models were being selected, model evaluation was going on. If you remember, this is a complex process happening, so many things. You would want a platform which really observe and check if there is any error or not. The metrics related with your models are being pushed properly, so you have a system which validate. If there were 10 models were selected, you want to know which model was winner and what parameters were higher comparative to others. So you need all that data. To manage all that data, we have something called the machine learning observability or monitoring platform. So the everything it sets as a MLOps. So MLOps stands for machine learning operations, like a DevOps, MLOps, and its job is to make sure that your machine learning pipeline combined with training, tuning, all the way to inference, model deployment, all that thing what we have here, that all can be considered part of MLOps. So all that blue here is part of MLOps. I didn't put the data preparation because that is not part of MLOps. MLOps believe that you give me machine learning ready data and I will process onwards there. So you have got the idea of MLOps, why they need it. And there are tons of companies in existence right now, such as Fiddler, Arise, Verta. I have put some of them name here: Arthur, Neptune AI, Comet, OctoML, ClearML, Nimble AI. Some of these platforms I have actually created lots of tutorials, video, hands-on lab. So please feel free to check out my YouTube channel, and you are going to get lots of information related with these platforms. I love MLOps. It's been almost 5-6 years I'm working in this field. observability or monitoring, they want to track all your ML experiments. Everything happen in those phases, all the models are being reported. All that information, what is happening, is going to be recorded. So out of these, if you are using platforms like H2O or driverless AI or data robot, all of these platforms also gives you the built-in MLOps capability. They will give you all the experimentation details. Your model metrics can be stored. You can always look into the experiment and you can go back in time. And that's where the concept comes that, okay, what is a MLOps architecture provides us that we can take advantage of machine learning training. So training, it took several hours to build your machine learning model, and now you have all that training data. So even your training has stopped. Looking into the data, how the training was happened, how the models were created, the metrics, etc., comparison in between, the time taken to the training, all that thing can be recorded in this MLOps platform. So they all can be reviewed as needed. So MLOps architecture is designed in a way that wherever the experiments are running, because experiments could be running on-prem, could be running in cloud, and these experiments could be running in variety of engines, libraries, platforms, whatever you have. So bringing the MLOps platform where all the data related with your experiments has to be managed in a way that the data sent from these experiments will be available wherever you want to access it. So the most common design is that all that experiment related data is stored in the cloud, and wherever you are trying to run this experiment, you send all that data automatically just by writing few lines of code. So here in this MLOps architecture, let's go a little more deeper here. So these are your MLOps platform. If you look into the connectivity, they are connected in a way that these platforms where you are performing your machine learning experiment, wherever they are running, it does not matter as long as you have ability to connect your experimentation to the MLOps platform. That's all what needed. So we can look into a little more deeper that all those real-time metrics, they are being sent from your experiment to this MLOps architectural or the platform where everything is happening, that some piece of code is injected into your ML experiment, and now whenever your experiment is happening, the real-time metrics are being sent from your runtime environment to this platform, observability platform. And depending on how long your experiment run, the metrics are being sent periodically, and the operation of that experiment can be real-time checked on those monitoring or observability servers. Some of them are available on a local local machine, means you can run locally. So there is a company called ClearML. They are from Allegro AI. They have the system where you can run the monitoring server locally on-prem. However, majority of on-prem companies, they keep their server in cloud, and you just need to create your account, and somehow you bind that account and the experiment ID with your SDK, and all of your experiment data will be pushed to those cloud servers. And then you have this web application where you can peek into the files, what you are pushing, what kind of metrics you have, the all those model metrics, your training metrics, all the iterations, all the engines, everything what is happening, everything depending on library you are using, the MLOps platform you have selected, everything can be recorded and reviewed after the experimentation is done, as well as while the experimentation is in progress. And looking into the MLOps architecture, most of these guys, they have the Elasticsearch, so you could search, because most of these data is coming into these metrics and profiles. They are JSON files, so they are dumped into the Elasticsearch, and then it's structured in a way that everything is indexed, so you could search based on in your JSON keys. in memory data, so database, so data can be pushed faster to you. So the visibility of the data metrics, everything is really very fast. Relational database, so some of the structured information can be stored properly. Key value store, they could have time series database they can add. So depending on the extensibility design within the MLOps architecture, this is what you are really going to see. And if you would want to build your own, you can actually use the open source platforms such as Prometheus to send the events, and then you can use the data hub for the lineage and the variability in the data, and you can actually come and build your own too. It's gonna be a little hard, it requires some engineering capabilities, but you could build also. So this is what your ML ops architecture. And now we have understood that whenever you are doing the ML ops, you are going to get the experiment data as well as the model metrics. Now the role of model registry comes, because if you believe that you have an environment where you do not have the model registry, it means experiment is done, everything, now you got your final leader model. Now you have to take that model and you need to deploy it. If you do not have a model registry, you do not have a way to save your model, the problem is going to happen is that if you are doing the various iteration, how you will know this model is better than previous one or not? Because you may not have good way to validate which model is better. So model registry is the place where your model information is saved, or model itself as of object, file object is really saved. And sometimes these model could be very big. They could be size in gigs, depending on what you are really trying to process. So it's all depend on what has been given to the model, so that it's trained on that information, collect all those signals and build its own learning. Because when model is performing a prediction, it does not look upon anything. It has everything built into itself, and you give the incoming data and it performs the prediction. It means it has everything it needs in order to generate the score or prediction. So it could be sometimes very big. So you really need to know models, their score, variety of parameters they were used when this model was created. All that thing you have to have stored, that information is stored somewhere, and that's where the role of model registry comes. Model is stored, experiment details are stored, and if you are trying to have the various models related with the same experiments, they are stored. Now you have very quick way to validate that which is the best or the winner model across multiple training. So if you have a business model where new data is coming on daily basis and you are training your model, and sometimes the new data is there which trains your model, but still you are using a model which is best across multiple time slices of training. So model registry is going to definitely help you to select which model is better among all these model, because you have all those metrics stored there. So you have got the idea of model registry, and now your machine learning deployment pipeline is not depend on your machine learning training pipeline, because machine learning deployment pipeline will always pick the best model to deploy from the model registry. And if there is no model, then no deployment happen. But anytime if the machine learning training process happened for a particular problem and models were generated and they are stored in model registry, then deployment pipeline will have no problem to pick up the best winner model, whether it's a flagged for best or whether it's based on certain metrics evaluation which model deployment process can choose. It's all depend on how the MLOps engineer are really setting all that model deployment process now. So model registry does help us to 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 remove the dependency between the deployment pipeline and the training and tuning pipeline. And that's a very good, because otherwise you are really basically inviting more trouble for yourself and for IT folks. So now we have learned the value of model registry, MLOps platforms, their applicability in our uh, machine learning or deep learning or the AI pipeline. and how valuable they can be. Now it's depend on which particular platform you have chosen and how capable it is. One thing you have seen a couple of places, I have written ONNX model. And what is ONNX model here? So ONNX model is a type of model which is based on certain guidelines. So the Microsoft, Facebook, and a couple of other organizations, they joined together and they decided that let's create a format of model, a standard of model. So ONNX model is basically a standard model agreed upon two or more organizations. So it means that if you build a model, you can convert that model to ONNX model, and then you can bring ONNX model back to the source model too, depending on capabilities in the libraries. However, if you have a core ML model, which is the Apple iOS model format, because Apple uses the core ML library, so core ML is their model type. You take core ML model and you convert to ONNX model. And now ONNX model is a general model. It is core model gives immediate thought process, or it's a Apple framework thing. If you have a H5 model, which is the deep learning model, because it has the weights and coefficients and all other things related, network layer, all that information in that H5 big file, then you know that is deep learning model. Or if you have the Pojo, then you know it's a Java based training system, could be H2O, could be deep learning for J, or could be something else. So depending on what these models are, you make them a standard base, and that's where the ONNX model is. So certain model registry, they have capability that one-click deployment or one-click transformation, you take a model and it will give you as a ONNX model. And ONNX model, once you have these models, there are a couple of ways the advantage of ONNX model could do. Sometimes you create models, the models are bulky, and then when you are performing the prediction or scoring, that might take longer. And depending on your business requirement, you want to get production done at super fast speed. So ONNX model has capability to take this whole your transformed model and can be break into a C++ code, or C code, or Python code, or Java code, Scala code. So production time could change. It is very much possible that you might improve by transforming your model from source model to ONNX model, or it may not. But this is another way that ONNX model can definitely help you. I have seen personally that Java Pojo models, they can be converted into C++ model, and then you are going to get very high scoring speed or inference speed in your predictions, because there will be no overhead for JVM and all that thing. So those are a couple of things you can choose in your platform requirement if the ONNX model is going to fit for you. So we have got that thing covered. A couple of things we have seen in our pipeline. One is the code artifact, another is the model artifact, and we have also seen the data artifacts. So what are these and what is the role of them? So because we just talk about model, so we can get little more information about model artifacts and code artifacts very quickly. So model artifact is basically the information around the model when it was created. So you know the model metrics there, the drift, if this model is really working well with the data drift or not, the explainability, interpretability, accuracy, all the metrics. You know, there could be host of metrics, and depending on your business requirement, you will choose this model. Sometimes you use RMS or MSE or RMSE. You are using R square. Okay, somebody would like to use the ROC depending on AUC. So there could be several metrics. So all that information will be part of your model artifacts, and that all has to be stored in model registry so it can be checked upon. So if you do not have a model registry, you need to find a way to store all that data related with the model. And if you have a bunch of model where you would want to interchange depending on your need, you have to have these model artifacts. So model artifacts, they mostly go into the model registry where whenever needed, you can peek into and you can review them. The code artifact, if you look into, is all related with your machine learning, training and tuning pipeline. So when you are doing the experimentation, we talk about you select algorithm, you select the parameters within the algorithms. So how you do that everything? There could be a lots of information. You selected this engine, you selected this algorithm, and these are the list of parameters. You use the hyperparameter optimization. So now you are actually doing experimentation based on various values within those parameters. So all that data could be the code artifact. If you have written a Python code, that's your code artifact. How many times you have run, how many experimentations you have done, everything is part of code artifact. And that's you have to store somewhere. So majority of the time, the code artifacts also is stored in your MLOps platform. All the code, whether you are using Jupyter Notebook or your Python code or C++, whatever code you have used for performing all that thing, maybe you use YML file, which has all that parameter configuration. It could be anything. All that information considered as a code artifact, and that also is stored, because if you have code artifact stored, you can start it up and you can latch on your incoming data and you can rebuild a model again. So it helps you to do the retraining. It helps you to figure it out if there were any problems or not. So if you need to perform the optimization within your engines, libraries, selection, so all that thing part of code artifact, and that also is stored into MLOps platform. Let's go a little more back and look into the data artifacts. Data artifacts, they are related with your pre-processing, because remember, when you started pre-processing, your data was clean, joined, ready for machine learning. It was ready for machine learning preparedness. It means it has to go through with normalization, labeling, all that. If you are using unstructured data, image, audios, etc., you might need to label them. Data balancing, regularization, feature engineering, all those processes generate a lots of artifact, metadata, what had happened, all that thing. So all the data artifacts can also be stored, because if you could store that thing, it's easier for you to whenever something happens, you can restart the pre-processing, and those artifacts will help you to perform all your work. So all that data related with pre-processing considered as a data artifact, and that's where it is that if you store them, it helps you to re-engineer your pre-processing pipeline, where all the incoming data can be made machine learning ready very fast. And now it's a very good segue for us to start talking about feature store. So as you could see here in our pipeline, one feature store we have here that is used just between the machine learning ready data, and then the data is fed into the machine learning training. And the second feature store is used here when we are performing the inference or predictions. And if you look into this combination, you are going to see that we have feature store online and the feature store offline. So what is feature store? So feature store is just a very new advance in machine learning training pipeline or machine learning training system. And the way feature store helps you is that all the work what has been done in the pre-processing means you are creating new features, you are processing the features, because when your data is ready for pre-processing, you have few set of features here, and all of this work actually generate a lot more features. And features are, in normal or layman term, is these are the columns in your data. So your data is a collection of various columns, and each column is a feature. And when you are pre-processing your data, you are enhancing those features. You are making sure that the relationship between the data is really tightly, they are correlated very well. It means that you could build a better model, because if the data is very well understood between these columns or among these columns, you are going to get better machine learning results. So you are processing all that pre-processing, but if you will not save all that information, or you will not automate it, you have to do it again and again and again. So what feature store does is that feature stores gives you capabilities to create your pipeline which can work on your incoming data, and data could be coming out from whatever source it can be, and it can help you to build your features. So the role of data scientist in any organization is to search and discover features, define features and perform the transformations, generate the training data set. That's what pretty much data scientist does. And if we go look into our image here, and I just want to make sure you understood this point very well. That is what your data scientist is really doing here. Up to here was the data engineer job, but this was the very data scientist focused job because that's where their expertise are. So if we take this whole work and we bring here with the feature store, so all the work they are doing that can be created in terms of a pipeline. So feature store is a way to perform the feature discovery, model training, and batch inference, etc. So whether you have stream data or batch data, all that data can be sent into a feature store. So this is your feature store, and where it can be stored, transformed, served, validate, and monitor. So it will validate whether data is good or not. So you can validate if changing data happen, you can set the event, and event can be triggered, so it can be monitored. So the job of feature store is to register everything and discover the best features related with your problem. So several companies such as Feast, Hopsworks, they have open source feature stores available. Scribble Data is a new organization. I recently found out about them. They also have their feature store. And then companies like Databricks, they have their own feature store, which is part of Delta Lake. And Google, in the Vertex AI Cloud, they also have their own feature store. It's called the Vertex Feature Store. So these are advances in machine learning pipelines will be keep coming. Feature store is one of them. Feature store helps you to automate your feature discovery, write once, apply all the time. And if you have a feature store, the good thing is that you can automate all of this work what we have done here in this area, and that could be always working as soon as your new data is coming. So this pipeline, which is part of your data preparation pipeline, can be integral part of your feature store. So all the data which is coming out for your from your these sources and you are using for feature discovery, training, and batch inference, that's why it's called the offline feature store. The online feature store is really designed for inference, because all that data which is going to be used for prediction is really new data. And then what your objective is that you want that prediction to be happen in super fast speed. So that's why you have an online feature store, which is just a low latency database, and that's for a real-time result you could get. So new data is going to be coming that will be available into the online feature store, so it can be sent for predictions. However, the older data where all that features were created, processing happened, and then finally you created the training data that was sent for machine learning, that was offline feature store. So in the offline way, what is happening is that data is being sent, processing happen, training data is created, and training data was sent to machine learning processes, and then your model was generated. When the new data came, same transformation will be applied. Now that data is stored into this online feature store where it's being sent for predictions, and that's what the role of feature stores are. So with the help of feature store, you have capabilities to perform super fast predictions. That's one capability. However, the work which was needed on both sides when the training was happening as well as the inference was happening, you have to perform the processing on incoming data. That all can be done through the pipeline at one single place. And we do not need to store all that data because the data is already stored, whether it's a stream data or batch data. If your stream data is coming, you would want to key it and you want to store all that data in your data lake or Delta Lake or data warehouse. That that you could do it, because whatever data is coming into the stream in the feature store, that's going to be applied for feature discovery and readiness for training, data readiness for training. So what we have covered today in this deep dive of machine learning pipeline. We have covered machine learning training systems. We went more deep, and then we looked into the various libraries and framework and how they fit into the cloud and on-prem world, and how these platforms such as driverless AI from H2O.ai, Data Robot or Data IQ, they all fit into the combination with Microsoft Azure, Google Cloud Platforms, AWS SageMaker or AWS Cloud, all that things. We looked into that. We studied the AutoML, blending, stacking, how everything works, the origin of ONNX models. We went and looked into the MLOps architecture. We also looked into the MLOps platforms, why they could be useful for any organization, the use of model registry, how it helps us, and the combination of the data artifacts, code artifacts, and the model artifacts, they all need a place to store. So the code artifacts and the model artifacts, most probably they became part of your MLOps platform where they store, versus the code artifacts could mostly go and they can be stored into the feature store. And if you don't have feature store, then you might need to find a place to store them also as needed. So we have covered these 5 key things which are part of the advanced and the smart or the latest machine learning pipeline. I hope you really enjoyed this discussion. I really wanted to share what I really have in my mind related with AI pipeline, and my objective was that you can get all that information, so whenever you are going to work, you have good understanding of what you are doing and where all these different libraries and components work together to solve a particular problem through machine learning training. So that's all I had for you in this tutorial, and I'm going to look forward to seeing you in my next tutorial. Until then, thank you so much. Thanks for your time. Please like it, share it, and subscribe it.